So in this video, we're going to talk about closed input-output models. Basically, for a closed input-output model, everything that is produced is consumed internally with nothing left over for outside demands. So, when I think of this, I think of the person who creates a vegetable garden for their own cooking. Everything they make, they're using. They're not making it for profit. They're not making it to sell. They're making it for self-consumption. So, since everything produced is equivalent to everything that is consumed, we can, let me grab a pen here, we can say that the matrix X is equivalent to the matrix AX, where X is our production matrix and AX is what we consume in creating X. And so since everything that's produced is equivalent to everything consumed, if I do a little bit of matrix algebra here, I can subtract AX from both sides. And if I wanted to, I could pull out X as a common factor, leaving me with the identity matrix minus A times matrix X equals 0. Now this resembles the formula we were using when we were calculating input-output models, and if I look at this, I can see that the outside demand is 0. So, let's go ahead and look at a problem. Scroll up here. I apologize, I know that's a little fuzzy, but this is number 28 from the section we were working on, 2.6, I believe. 2.6, number 28. So let's go ahead and just take a look at this. The production of 1 unit of agriculture requires 1/3 of a unit of agriculture. So I'm just going to build a little matrix here, and this is going to be matrix A. Matrix A says that to create 1 unit of agriculture, we need 1/3 of a unit of agriculture, 1/3 of a unit of manufacturing, and 1/3 of a unit of transportation. And what I'm looking at is just this first sentence. The second one, to produce 1 unit of manufacturing, that requires 1/2 unit of agriculture, 1/4 unit of manufacturing, and 1/4 unit of transportation. So I'm just going to fill this into our matrix. And then the last one, to produce 1 unit of transportation, requires no agriculture, 1/4 unit of manufacturing, and 3/4 of a unit of transportation. So let's write that in. So we're creating transportation. 0, 1/4, and 3/4. Okay, so here's my matrix A. Find the ratio of the 3 commodities in the closed model. That's what we're trying to do. So, let's take another peek back at this equation here. Since my outside demand is, since my outside demand is 0, my outside demand is 0, I have the identity matrix minus the matrix A times matrix X. We're just going to write this out. And I'll do it over here. I minus A times matrix X equals 0. Well, the identity matrix, I'm dealing with a 3 by 3, so the identity matrix is going to be that. And I have the identity matrix minus matrix A. And then whatever this is, whatever this thing is, I'm going to multiply it by matrix X. Now matrix X is going to represent, let's see, the number of units of agriculture, number of units of manufacturing, and the number of units of transportation. This is my production matrix. And this product should equal 0, which I'm going to write as a 3 by 1 zero matrix. Now, the nice thing is we have some technology here, and I can lean on my technology a little bit. I've already taken the liberty of entering... Do it. You can turn on. Okay. Seriously? Okay, I've taken the liberty of entering into my matrices. I put the identity matrix in matrix I. I put this in for matrix A. And I want to figure out what this piece right here is. So I'm going to go to my calculator and quit. And I'm going to do the identity matrix minus matrix A. Let me go and put in a minus sign there. Okay. See what I calculate. Now, what I want to do is I'm going to store this. I'm going to write this as fractions. And I am going to store it by clicking this STO at the bottom. I'm going to store that as matrix B. Okay. So here's my new matrix B. Now if I multiply it by these three variables, the number of units of, what are we talking about? Number of units of agriculture, manufacturing, and transportation. I'm going to use these for my variables. And if I look at this, okay. So if I look at this, I can fill in this identity minus A matrix, and it is 2/3, let's see, it's 2/3, negative a half, 0, negative a third, 3/4, negative a fourth, negative 1/3, negative 1/4, and 1/4. And if we do a little bit of matrix multiplication here, what I can see is that as I multiply these, what I get is the system 2/3 A minus 1/2 M plus 0T equals 0. Looking at the second column, I have negative 1/3 A plus 3/4 M minus 1/4 T equals 0. And then the last one I have negative 1/3 A minus 1/4 M plus 1/4 T equals 0. With this, because I have a system of three variables, I can create an augmented matrix. And using the calculator, I can convert it to reduced row echelon form to see how many units of agriculture, manufacturing, and transportation I'm going to need. So really, I was just going to copy these coefficients back down into my augmented matrix. You guys can imagine what that would look like. I did store on the calculator, I stored this matrix into my calculator as matrix B. And so to create the augmented matrix here, I am just going to go to second matrix. And I'm going to take matrix B, which has this 2/3, negative a half, 0, negative a third, 3/4, negative a fourth, negative 1/3, negative 1/4, and 1/4. And I'm going to go back into my matrix menu, and I'm going to edit matrix B. I'm going to add a fourth column. So instead of a 3 by 3, I want it to be a 3 by 4. And what it does is it saves all of the elements that I had from before, but it adds that third column of zeros. Now all I have to do is go to, let me quit this. I'm going to go to matrix, and I'm going to do some math. I'm going to take matrix B, put it into reduced row echelon form. And what this tells me is that I have 1, 0, convert that into fractions here. 1, 0, negative 3/8, 0, 0, 1, negative 1/2, 0, and then zeros across the bottom. So if we look at this last line here, what that tells me is that there are infinitely many solutions, and if I use the last variable as my parameter, then what I can do is represent the first two. So looking at this again, I have negative 3/8. Let's take a look at what that was. Negative 3/8 represented transportation. And so this piece right here tells me that if I look at this line, I can create an equation. This was, let's see, so the first column represented agriculture, manufacturing, and transportation. So from this first line, looking at what I do have, this tells me that 1 unit of agriculture minus 3/8 units of transportation is equivalent to 0. Or I could think that 1 unit of agriculture is equivalent to 3/8 units of transportation. Looking at the second line, what this tells me is that 1 unit of manufacturing minus half a unit of transportation equals 0. So manufacturing is equivalent to half a unit of transportation. And then transportation is 1 unit of transportation is just 1 unit of 1 unit of transportation. So looking at this, if I was looking for a unique solution, I won't be able to find one, but what I can do is I can write the 3 in terms of transportation, and it would be 3/8 t, 1/2 t, and t. Now the question is really asking about the ratio. So if I wanted to go through and clear the fractions, if I had 8 units of transportation, if I have 8 units of transportation, then I would have had 3 units of, I have to cheat here and see what we're talking about here. So I would have 3 units of agriculture and 4 units of manufacturing. Oops. So the ratio then is going to be 3 units to 4 units to 8 units of all 3. Okay, and that is that.